and welcome. On this video, I'd like us to discuss the solution to this problem. Okay, so they were saying use an augmented matrix and Gauss elimination to solve the given system. Give the most general solution where applicable. Show your answer is correct by using it to solve the system. So they give us the equation x minus y plus 2w equals to 4. So you're actually having 4 parameters. Then the second one minus x and y plus z minus 5w equals to 3, then 2x minus 2y plus z plus w equals to 15. Okay, let's quickly from that make an argument matrix. Okay, so the argument matrix is going to be 1 minus 1 0 2 on the first row. It's going to be 1 minus 1 0 2 equals 4. Then we want to have minus 1 1 and 1 again, 5, minus 5 3, ne? Then 2 minus 2 1 1 and 15, like that. Okay, so what we have to do now is to apply our operations. Okay, the first thing that I would like to do now is that I want to interchange these two rows, since I realize this one is containing infinitely many ones. Okay, so once I'm going to edit with this one, I'm going to get zeros quicker that way. So the first thing that I'll do is to exchange the rows. So I'm going to exchange row 2 and row 3. So row 1, it will remain like that. 1 minus 1, 0, 2, 4. Then I'm exchanging row 2 and row 3. So I'm going to get 2 minus 2, 1, 1, 15. Then minus 1, 1, 1, minus 5, 3. Like that. Okay, so now on this augmented matrix, I can start applying operations. So I'm gonna apply operations on row 3. On row 3, I'm just gonna say I want a 0 there, so I can edit with row 1. Okay, so I can say row 3 plus row 1. So this is the equation that I'm gonna be using to operate row 3. So I'm only operating row 3. All other rows are gonna remain the same besides row 3 alone. So that will give me a new matrix where row 1 remains the same, 1 minus 1 0 2, then 4, and row 2 also remains the same, minus 2, that is minus 2, that is 2, minus 2 1 1, then 15, like that. Then what are we gonna get once we operate here? Here we see that we're gonna have minus 1 plus 1, that will give us 0. Then minus 1 plus 1 again give us 0. Then 1. Then 2 minus 5, that will give us minus 3. And 4 plus 3, that will give us 7. Okay, so now the next thing that I want is a 0 there. I'm actually converting it into a row echelon form, right? So I want a 0 up there. So the thing that I'm gonna do, I'm gonna use this 2. So I'm gonna multiply this row by 2. Okay, so on row 2, I'm gonna do the following operation. I'm gonna say row 2 minus 2 row 1. Okay, so I'm only changing row 2. So the new matrix that I'm gonna get there is gonna look like 1 minus 1 0 2 4. Then let me just keep row 3 as it was, 1 minus 3, then 7, like that. Okay, so I'm only going to change row 2. So you see row 2 minus 2 row 1. So I'm gonna have 2 minus 2 by 1, that will be 0. Then I have minus 2 plus 2, then I'm gonna have 0 again. then 1 minus 2 by 0, that will give me 1, and 1 minus 2 by 2, that will give me minus 3, and 15 minus 2 by 4, that will give me 7. Okay, so now that I've applied operations to get this, I can further go on to row 3 again and apply operations. I want a 0 there, so if I want a 0 there, I have to subtract these two rows. So I'm gonna say row 3 minus row 2. Okay, when I say that row 3 minus row 2, what I'm getting is gonna be a new matrix. Let me go this way since I no longer have space there. I'm gonna get a new matrix where I'm keeping row 2 and row 1 exactly as they were. So I have 4, 7, like that. Then minus 3, 2, 1, 0, then 0, minus 1, and 1, 0 again, like that. So we're only going to change the last row. Okay, so we're saying row 3 minus row 2. So we're going to say 0 minus 1. Nah, not 0 minus 1. I meant, since you're saying row 3 minus row 2, so it's 0 minus 0. So here we're still gonna have 0, and also there 0 again. Then 1 minus 1, 1 minus 1 from that equation. So you're gonna have 0 here. Then you're gonna say minus 3 minus minus 3, then 0 again. 7 minus 7, then 0 again there, like that. Okay, so now we got something like that. Notice that we can't do anything further on this matrix once it is in this format. Okay, because now if we try to make a 0 there, like if we are chasing Gauss Jordan elimination, we try to also make a 0 there. How are we going to obtain that? If we use these two rows, we can make a 0 there, but that is going to change this 0 here, because here we have a 1, so it's going to change there. So there's no point in doing that. Okay, so what we can do now is to have our equations. So on the last column, we see that we have zeros, all zeros. So we can say that implies, remember here we have x. This is a column for x. Then this one is for y. Then this one is for z. And the last one here is for w. This one is for w. So we can just simply say w is equal to t, where t is an element of real numbers. Why do I say w is equals to t? Notice that if I say 0 by w is equals to 0, whatever value of w that we're gonna have there, it will satisfy the equation. The equation will always be true. Okay, so then now we can come to this one and say we have z by 1. That will give us z minus 3 by w, minus 3 times w, but we know w is t, so I'm gonna right away substitute t there is equals to 7. Then that has to simplify to z equals to 7 plus 3t. Okay, then we're gonna go to this first row. On the first row, we see that we're gonna have x minus y, then z by 0 goes away, then plus 2w plus 2w, but w is t, so I'm just going to say 2t must be equal to 4. So if we take this to the other side, we're going to have x minus y equals to 4 minus 2t. Okay, so in this case, we see we can't solve for x and y separately, because yeah, that is the case. Then we can say, oh, this logically makes sense that in this case x has to be 4 and y has to be 2t. Okay, so that will imply x has to be 4 and y must be equal to 2t. Okay, then our solutions here, x is 4, y is 2t, z is where is z? We got it there. It's 3t plus 7, and w is t, like that. So those are our solutions. So this is how you find your solutions. Okay, so now here they say show that your solution solve the system. So in order for you to show that, you have to choose a value of t. Notice that they all depend on t. Okay, w depend on t and z depend on t. It's only x that is fixed. X is fixed, is a fixed value of 4. Otherwise y and z depend on w. Okay, so if we choose t to be 0, let's choose t, if we choose t to be 0, what is going to happen on the first equation? The first equation is this one. It says x minus y plus 2w equals to 4. Okay, on the first equation, what is going to happen is that x, we know it's 4, it's not gonna change. Then it says minus y, and we chose t to be 0, so y is going to go away. Then plus 2w, and we chose t to be 0. Since w is t, that will also go away. So 4 is equal to 4. So equation 1 is satisfied. Then on the second equation, we are still choosing t to be 0. Let us see what is going to happen. On the second equation, we're going to have minus x, and we know that x is 4. So we have minus 4 from the left hand side. We have minus 4. Okay. Then minus 4 plus y. Y is going to be 0. Since t is 0, y is still 0. So plus z. If we plug t to be 0 there, notice that z is going to be 7. So it's minus 4 plus 7 and 5w. W is t, so this will go away. So 4 plus 7, that should give us 3, and we see it's equal to the right hand side from the equation. So also equation 2 satisfies it solves the system, satisfies our equation. Then the last equation, equation 3, it tells us that we have 2x minus 2y plus z plus w. Y and w are both zeros, so we are worried about 2x and z, so they must give us 15. So we know that we want 2x, so 2 by 4, then plus, it was a plus, right? Yeah, it's a plus there, plus z. So we said this will go away, then z is 7, so plus 7. So this is basically 2 by 4. 2 by 4 is 8. 8 plus 7, that is 15, which is the same, not 18, but 15, which is the same as right hand side. So also that satisfies our equation. So we can choose, since they all depend on what t is, we can choose t to be 1 and see if that will still be the case. If t is 1, what is going to happen now is that w, basically we are saying w has to be 1. If t is 1, it implies w must be 1. If w is 1, then here z will be equal to 10, and y will be 2, and x is fixed. We know x is still going to be 4. 4x doesn't have any t. So yeah, w is 1, z is 10, y is 2, x is 4. So let's see from first equation what is going to happen. From first equation, we know that we have x minus y plus 2w. So we want it to be 4. So our x is 4 minus it's going to be 4 minus y is 2, so it's 4 minus 2 and plus 2 into 1, so w is 1. Okay, so that thing, it has to be, this 2 will cancel each other out, is equal to 4, which is the same as the right hand side. So equation 1 is still satisfied even though we changed our value of t. So let's check equation 2. So equation 2, it says minus x plus y plus z minus 5w. So minus x shows that we have to have minus 4, since our x is 4, so we have to have minus 4. And our y, we know it's 2. Our y is 2, so minus 4 plus 2, and minus 4 plus 2 plus z. So z is 10. So this 10 here, we see that we said our z plus 10, then plus 10, then minus 5 into 1. Okay, minus 5w, says minus 5w there. Okay, minus 5w. So we expect that to give us an answer of 3. Okay? We expect it to give us 3. So let's simplify. Minus 4 plus 2, that is minus 2, plus 10, that is going to be minus 8. 8. Then 8 minus 5, that is going to give us 3, which is the same as right hand side. Okay, so we can prove the last one now. The last equation says